What I'm going to do in this video is show you how to go to these data on the softball hitting distances for males and females and use the T.Test function in Excel to see if boys really do hit further than girls. So in this article I'm going to go to the link with the softball data. It's going to bring up the Excel sheet. And here are the data. I'm going to show you something that might be helpful to you later. I'm going to highlight and notice that all the data are softball hitting distances in feet. So here I've selected all the softball hitting distances we have for females. I'm going to go up here and name this data array female, and you'll see how this becomes useful in a little bit. Then I'm going to do the same thing for males. I'm going to highlight all the values for males and go. I'm going to name that array males. And you'll see that there are more observations for males than females, but that'll be okay. Next, what I want to do, let me show you something. Let me just look at the average hidden distance for male and the average for female. To calculate the average for male, I'm going to go equals average. And instead of selecting data, I'm just going to type male because I'd already named it. 171. The average for female is 92. Now, these data, males do hit further than females. But suppose we want to ask, do males hit further because they can really hit further, or was perhaps this just a random chance? After all, one average did have to be greater than the other. Was this due to chance, or do males really hit further? To answer this, we're going to use something called the T-Test. And I use it by, first I type in the formula, T-Test. In parentheses, it wants the first array, and I'm going to tell it the first array is male. The second array is female. I could have easily done female first and male second. For tails, I'm testing whether males hit further than females, not whether just males hit different than females. So this is a one-tail distribution. This is something you learn in introductory statistics that you may not remember. But basically, if you want to see if one thing's greater than or less than another, it's one-tail distribution. If we just want to know whether two things are different, we use a two-tail distribution. And then we have these differences in here. I'm going to assume that the variance of hitting distance for males and females are different. And so I'm going to select two samples, unequal variances. And I do this, and I get an absurdly low number. I'm going to change this to it's basically 0. What this means, now look at this is the result of the formula, basically 0. And what that formula tells us is that 0 means the probability that larger average hitting distance we found for males is simply due to chance. Another name for chance is randomness. Another name for it is stochasticity, is 0. So the probability that higher hitting distance for males is simply due to chance or stochasticity, that probability is about 0. And what this means is that we could conclude that males really do hit further. It wasn't just because of chance. Males do hit further. We conclude that, we're willing to say that because we know that the probability that we're wrong and that it was really due to chance is about 0%. I'm willing to take that chance of being wrong. You probably are too, so we say males hit further. Hope that helps.